Assalamualaikum and hi, welcome to our video. We are going to present on the topic of application of derivative. We are from course group of T1 CDCS 1103B. Firstly, I will introduce our group members. First is Tuan Nur Aisyah Damia binti Tuan Hassan. Second, Damia Batrisha binti Muhammad Nawi. Moving on to introduction to application of derivative. Differentiation finds application in addressing problems related to related rates. The concept involves calculating the rate of change of one quantity with respect to the rate of change of another quantity, which might be more conveniently measurable. Related rate problems encompass scenario where two or more variables undergo simultaneous changes, potentially at different rates. Application of derivative in real life. First, utilize for derivation of various equations within the realm of physics. Second, find out the velocity or the distance traversed. Lastly, we have monitor on the temperature of different objects. Problem statement. A water tank poured water into a conical tank at the rate of 9 meter cubed per second. The radius of the conical tank is 4 meter and the height is 12 meter. We have to find the rate of water rising level when the water reaches 4 meter deep. The first one in the problem solution is that we have to collect all the important information provided, and we have assumed that 9 meter cubed per second is the dVdt. dVdt is the rate of water poured into the tank. Meanwhile, dR/dt is the rate of water rising level that needs to be searched when h is equal to 4. The equation dV/dt equals to dV/dr times dR/dt is the equation we built in order to get the rate of water rising level. So the first step is to implement and use the formula that has been provided by the question. We use a triangle to visualize and imagine the shape of radius and height. From the info, we will have to search for the radius, which will lead to 4/r equals to 12/h. And then we will have to use the cross multiplication or just change the position so that the equation will end up being 4h equals to 12r. Moving on to r equal to 4h over 12, and last answer we will have is r equal to h/4. So the trick to answering this question is that we have to keep changing the position so only the radius is left on the left side of the equation. Continue the calculation until the answer is simplified.
And for now, I am Damia Batrisha. We'll continue our group presentation for application of derivative. I will continue by explaining on our solution for this question. As has been discussed by Aisha just now, we already get the radius for this cone using the cone formula, and it is h/4. And with that, we can use it to find the volume of the cone by using the formula again, the formula of cone, where it is 1/3 pi r squared h, and we will substitute the r radius with h/4. After substituting the r in the formula, we will get the volume equals to pi h³/48. By using the equation of the volume just now, pi over 48 3h squared, we will differentiate the equation with respect to rate r. We will get dv over dr equals to pi h squared over 16. Now, using the function of dv over dt equals to dv over dr multiply with dr over dt, we can find the rate of water rising level when the water reach 4 meter deep by searching for dr over dt. These two values will be used to substitute the function. The first one is the value for dr over dt, and it is 9. And the value we got for dv over dr is pi h squared over 16. Since we already find for dv over dt and dr over dt, substitute the value into the function to find dr over dt. And we will get 9 over pi. Since the water is poured into the conical tank, the volume of water in the tank is increasing at a constant rate of 9. Therefore, dr dt is equal to 9 over pi. For our conclusion, implementing cone and triangle shape in order to visualize the height and radius of the conical tank. Applying differentiation to get the derivative of tank volume. And construct a function based on information given. And these are our reference. And that is all for us. Thank you for watching and for your time. Have a nice day.